Hello everyone. In this lecture, we are going to study Fourier sine transform. In this, we are going to obtain formula for Fourier sine transform and we are going to solve example on Fourier sine transform. So let us see Fourier sine transform, for which we need to consider Fourier sine integral representation, which is given by f of x is equal to 2 upon pi integration from 0 to infinity f of v sine lambda v into sine lambda x dv d lambda. Now, the Fourier sine transform is given by these highlighted terms. So therefore, Fourier sine transform, it is denoted as Fs lambda. S stands for sine transform, which is equal to integration from 0 to infinity f of v sine lambda v dv. Then the inverse Fourier sine transform is given by, now replace this integral by Fs lambda in Fourier sine integral representation. Hence, inverse Fourier sine transform is given by f of x is equal to 2 upon pi integration from 0 to infinity Fs lambda sine lambda x d lambda. To get the more symmetric form, we split this 2 upon pi into two equal parts and that will give us, in more symmetric form, Fourier sine transform is given by Fs lambda is equal to square root of 2 upon pi integration from 0 to infinity f of v sine lambda v dv, and the inverse Fourier sine transform is given by f of x is equal to root 2 upon pi integration from 0 to infinity fs lambda sine lambda x d lambda. We can use any of the two formulae, that is either in the symmetric form or the earlier one. As like the Fourier cosine transform, here the requirement is f of x should be an odd function in the interval minus infinity to infinity. So this is important, f of x should be odd function. Second, if we want to obtain Fourier sine transform, then interval must be 0 to infinity. So these are the requirements. Now we will go to solve examples on Fourier sine transform. So consider the examples. First example is find sine transform of f of x is equal to 1 upon x. Solution. So given we want to find Fourier sine transform. So it is given by Fs lambda is equal to square root of 2 upon pi integration from 0 to infinity f of v sine lambda v dv. Here we are using the symmetric form of the Fourier sine transform. We can use the earlier also. Now given f of x is equal to 1 by x, hence to find f of v, we replace x by v. So that will give us f of v as 1 upon v. Replace this f of v in the fs lambda. It becomes square root of 2 upon pi integration from 0 to infinity 1 upon v sine lambda v dv. And now we will try to solve it further. For that, we will make the substitution as lambda v is equal to u. Hence, v is equal to u upon lambda. So we have divided on both the sides by lambda. Differentiation will give us dv is equal to du upon lambda, and the limits will remain same, 0 to infinity. Therefore, Fs lambda is equal to square root of 2 upon pi integration, limits are from 0 to infinity. Now we have replaced the value. So lambda upon u into sine u dv is replaced by du upon lambda. This lambda will get cancelled and we left with Fs lambda is equal to root 2 upon pi integration from 0 to infinity sine u upon u du. Now we know that this is the sine integral whose value is equal to pi upon 2. So fs lambda is equal to root 2 square root of 2 upon pi into pi by 2, because we know that value of this sine integral is pi upon 2 in the limit 0 to infinity. So simplify this, fs lambda will be square root of pi upon 2. So that is the Fourier sine transform. I hope you got this example. Now we will go to the next example. Find inverse sine transform of fs lambda is equal to 2 minus lambda for lambda lies between 0 to 2 and fs lambda is equal to 0 for lambda strictly greater than 2. So we want to find inverse Fourier transform, which is given by f of x is equal to 2 upon pi integration from 0 to infinity fs lambda sine lambda x d lambda. Here we can use symmetric form also, but right now we have considered this form of the inverse Fourier sine transform. Now given fs lambda is this, which is defined on the two intervals 0 to 2 and 2 to infinity. So according to this, we will split our integration into two parts like this. So 2 upon pi integration from 0 to 2. See, first interval is 0 to 2. fs lambda sine lambda x d lambda plus 2 upon pi. Second interval is lambda is greater than 2, means interval is 2 to infinity. Hence integration from 2 to infinity fs lambda sine lambda x d lambda. Now replace the value of fs lambda from the respective interval. That is, for first integral fs lambda will be replaced by 2 minus lambda, and for the second integration fs lambda will be replaced by 0. Therefore it becomes f of x is equal to 2 upon pi integration 0 to 2 minus lambda sine lambda x d lambda plus second integral, its value is 0 because fs lambda is 0 in 2 to infinity. Now to evaluate this integration, we will use general by part rule, which is integration uv dx is equal to u into v1 minus u dash into v2 plus u double dash into v3 minus so on. Here dashes denotes derivatives, suffixes denotes integration. That is, we have to evaluate derivative of the function u, successive derivatives, and we have to evaluate successive integrals of the function v. Therefore integration will be 2 upon pi u, that is 2 minus lambda as it is, integration of sine lambda x, which is minus cos lambda x upon x, minus sign to the second term, derivative of u, that is 2 minus lambda with respect to lambda is minus 1, and integration of cos lambda x is sine lambda x upon x. So denominator it becomes x square. If we evaluate further term, derivative of minus 1 will be 0. So no need to evaluate further terms. Limits are from 0 to 2. Now simplify these terms. Evaluate, perform the multiplication of all minus 1. So that will give us 2 upon pi. This minus outside into 2 minus lambda cos lambda x upon x. 3 times multiplication of minus 1. So it is minus 1 sine lambda x upon x square. Limits are from 0 to 2. Now put upper limit and lower limit, evaluate the value. It will give us 2 upon pi, 2 minus 2 0 minus sine 2x upon x square minus value at lower limit now. 2 minus 0 is 2, so minus 2 and cos 0 is 1, so minus 2 upon x minus sine 0 is 0. Now simplify this expression. It gives us f of x is equal to 2 upon pi minus sine 2x upon x square plus 2x. Take the LCM of the denominator. So the simplified form of the f of x is equal to 2 upon pi 2x minus sine 2x divided by x square. So which is required inverse Fourier sine transform. I hope you have got this. Thanks for watching this video.